Konnichiwa. Thank you for coming today. Today's Tech Talk is about Google Web Toolkit, called GWT, or how the engineers like to say it, GWT. We like to pronounce everything. So today I will refer to GWT as GWT. These slides are based on a talk that Ray Ryan did at Google I/O, and he was gracious enough to share those slides with me so I could share them with you today. So what are we going to talk about in this session today? We're going to talk about how to organize a non-trivial GWT application, a complex GWT application. And we're in particular going to focus on the client side, the code that lives in the web browser. And we're going to do that in the context of AdWords. AdWords is a user interface that we provide you to manage your AdWords account. And this is an application that we've created a new version for, and we used Google Web Toolkit, or GWT, to do it. To show you just a few screenshots of the new UI so you can see that it's not super simple, it is a little bit more complex. And please come to the URL at the bottom and you can find out more information about AdWords. If you remember nothing else, if you have to leave early and you want to know what are the lessons for this talk, there's kind of these three things. One, get the browser history right and get it right early, which means when you build your web application, make sure the back button, the forward button work, and make sure that your application is bookmarkable, so that if a user is in the inbox and they click a bookmark, that state is saved. If they're on page 2 of a 5-page wizard, you can save that state with a browser bookmark. Number 2, use an event bus to help fight spaghetti. If you've built a complex application, you may find that everything starts getting tied to everything else, and it's very difficult to move pieces around in the application. A tool that you can use to avoid this is called the event bus, which I'll go into during the talk. Another is DI plus MVP FTW. What does this stand for? It's just a cute way of saying Dependency Injection, which is a pattern, plus Model View Presenter. This is another pattern, and both of these I will discuss in this talk for the win. These will make you successful. In order to cover these, we have 3 themes to look at. The first is embrace asynchrony, which means understand that you're in the browser and it's asynchronous. Things do not happen synchronously, and just embrace it. Realize that it's there and do it for everything. The second theme is always be decoupling. Always make sure that the left side of your application doesn't know about the right side. And strive to achieve statelessness. Make sure that different components in your stack can be restarted or refreshed without any harm. So the first theme, embracing asynchrony. Remember that the A in AJAX, it stands for asynchronous. So I'm going to start here with a simple contact class. This is a model class in an address book. I have a name for the contact, which might be my name, and a number of details. The details might be a phone number, an email address, or an instant messenger handle or a URL. And I have a method here to get the details for this contact, to get the name. But you see that now we have all the information stored in this model object. Not only my name as the contact, but also all my details, all my phone numbers, all my email addresses, my birth date, everything. Now, if I have an application that maintains many contacts, then all this information must be sent from the server to the client, which is a large amount of data. And that's not very good. So let's look at a better way of doing this. Instead of contacts, let's only store a list of contact IDs. That can be very short. It's just a series of numbers. And then later, when we need this information, we can go retrieve those contact details. So at the moment in the user interface, when I try to view a contact, I can go to the server and asynchronously fetch the details, fetch the list of phone numbers for my contact. Now we're going to use something called the command pattern to make asynchronous tolerable. The command pattern is a way of wrapping the things you want to do, like get information or update information. And it's a good leveraging point for caching. It allows us to make caching a little bit easier. It's also good for batching. We can take multiple gets of information, get contact A, get contact B, and group them together in one request to the server. It also allows us to centralize failure handling. So if a get fails, if it's a get for a contact or get for an email, it doesn't matter where it is in the application, I can handle it in one place and show the user an error message. This also lays the groundwork for code splitting. This is taking your Ajax application, your JavaScript code, and splitting it so that the initial download is faster and smaller. And when the user tries to access other pieces of functionality in the application, you download additional pieces. This is done via a method called gwt.runAsync, which we'll use today. It also lays the groundwork for undo and redo. If you've ever tried to implement undo and redo, you'll very quickly see the command pattern introduced. It also lays the groundwork for gears or HTML5 database work. So let's use the command RPC pattern. What does that look like? Well, we're going to define an interface. And I use the word action here because command is taken. Inside the Gwt libraries, we have already used command. So to make things easier, we're just going to use the word action. And we're going to parameterize the action by a response, what type of response it is. So we use type T, and we extend from the response interface. And the response interface, there's nothing in it. It's just a name, but it helps us. Now, when you do Gwt and define RPC, the remote procedure call, you define your methods, and you define an interface for those methods. So in this command pattern, we're going to create a single method called execute. And this is in the contact service. So we define this contact service interface, which extends remote service. This is a very standard thing that you would do in Gwt. We define a method execute, which takes an action parameterized by type T, and T extends response. That's it. So now we only have one RPC method instead of many methods, one for get, one for put, one for update. Everything is just one simple method. We also need an asynchronous method interface, and this is, again, just standard Gwt. We've taken the above execute method, and we've replaced the return type with the void keyword, and instead we pass in an asynchronous callback. And this is all very standard and looks familiar. Now, let's write the action. What does the action look like? Well, let's create an action called get details. I want to get the details for my contact. I want to get all the phone numbers, all the email addresses. So we have a field called IDs, and this is where we store the list of contact IDs that we'd like to get from the server. And we have a constructor, get details, which takes that list of IDs and stores them. And then we have a get method, which returns those IDs when we need them. That's it. It's very simple. Now let's look at the response. We do something very similar. Get details response implements the response interface. It contains a list of details that need to be returned from the server to the client. We have a constructor that stores those details, and we have a get method that will provide them to us. We also have, we'll write an asynchronous callback. This is a convenience class that will make the code within our application a little bit shorter and more convenient to write. What we're going to do is we're going to implement the onFailure method and just use global error handling within the application, so we don't have to deal with that for each and every case. And the onSuccess method is going to call another method called got. This is a new method that we're defining right here as a convenience. And that new method is here declared abstract, which means that when we use it in our code, we have to implement the got method. So you see that on success is implemented, it just forwards to got. On failure is implemented, it forwards to a global event handler. So when we use this class in our code later, we will only need to implement the got method, which will make it nice, compact code. So let's make it go, let's make it work. When we want to show a contact in the display, we call this show method. And what we'll do is we call the service, the RPC service, and we call that execute method. And we pass in two parameters. The first one is a get details. That's an action. And we give it a list of IDs that we want to retrieve, contact.get detail IDs. The second parameter is got details. This is that asynchronous callback that we created. And we only implement one method, the got method. And we call simply render contact and render details. So notice that this is asynchronous. When the user clicks on a contact and wants them to be shown, we actually make an asynchronous call to the server, request the details, and once we've received the result from the server, that's when we actually do the rendering. So there may be a slight delay. Now the second theme was to always decouple, always make the left side be disconnected from the right side. With decoupling, you take the combination of the event bus and dependency injection and the MVP pattern, and we'll talk about all those three things. And what we get is the ability to easily rejigger our app. That means to easily change parts of our application without affecting too many other pieces. So we become flexible in our development. It's easy to defer complicated operations in the DOM. And it provides easy unit testing, which is very important. Finally, we get fast execution tests. So always be decoupling. Let's talk about the event bus first. You might design your application like this, and in fact, I've designed applications like this. You begin with your model objects. These are the center of your design. In this case, we have contacts and groups of contacts. And this is where the properties are stored, like first name and last name. And these objects need to be hooked into the RPC service so they can update themselves and save their state, etc. We also have widgets in the UI which need to be wired into these objects. These widgets need to listen for event change properties. So anytime the value of my first name is changed, every widget that needs to update the screen is wired in via this event handling mechanism. As the UI gets more complicated, we wire more things together. And more. We might even want to update the window title based on the current contact we're displaying, and the breadcrumb or the navigation thread, we want to update that. And we've created a ball of spaghetti. If we want to change everything, everything else changes. And it's very difficult to keep track of the code and all the connections and make sure things are wired together. So let's loosen things up a bit. Let's take all the connections between widgets, so between the left side and the right side, and make those go away, and instead route them via an event bus. This makes it a little bit cleaner. Now we have less spaghetti, but it's still somewhat coupled. So let's loosen it up further. Let's take those model objects that are at the middle, where there's only one canonical copy of any model object. There's only one copy of me, and instead take them out of this design altogether. Now you might say, so where are your contacts? Where are your model objects? I don't see them on the diagram. Well, they've been moved to many different places. They are what's transferred across these lines. So if you have maybe the RPC service talking to the event bus, when an updated contact is retrieved, the RPC service will send that contact over the wire, over that line to the event bus. The event bus will take that update and broadcast it out to widgets that are interested about it. And you may in fact have multiple copies of a single contact in different states, but that's okay. And we've gotten rid of the spaghetti by taking the model objects in the middle and no longer having them be central to everything that we do. So let's look at implementing this. When we want to show a contact, we call the show contact method. We execute a service call. And we pass in get details, got details, and I'm sorry, this is the method we looked at before. What I want to do is update it a little bit. Instead, I want to make a change here. I only want to render a new contact when the contact that's being passed in via the event bus is different than the current one that I'm showing. So I add this little if statement here. Only if the current contact ID is different than the one passed in, then I call my rendering functionality. Let's see. The other thing that I want to do is I want to listen for contact updates so that if I'm currently a widget that's displaying a contact and I want to listen for the first name being changed, the last name being changed by another widget somewhere else in the UI, I know that change is going to come in through the event bus. So what I do is I register an event handler with the event bus. So to wire myself up, I call this method listen for contact updates. And I call eventBus.addHandler. And I give it a contact change type event. And then I create this contact change event handler class. And it implements one method, which is onContact change. And what do? Well, if the current contact that I'm displaying is the same as the contact being passed in, then this must be an update that I'm interested in. In that case, I call render contact so that my display updates. Now, we also, when we call the RPC service, what we really want to do is also update the UI. So instead of calling the real RPC service, we're going to call some intermediate. So here's that execute method. And you see what it does is it first calls the real RPC service, which makes a connection to the server. And then inside that, it does this other piece. So this is the same method, but now I just highlight the inside. We create this new asynchronous callback. And this is a little bit interesting. You see that the onFailure method here simply calls the original onFailure method in the original callback. The onSuccess method can do a few special things. First, it calls recache, so it can update any internal cache in the application on the client. Then it calls the original callback handler onSuccess method. That takes care of the work that we needed to do. And then we create this new contact change event. And then we throw that event on the bus. And the bus will propagate that event out to everyone who's interested in hearing about it. And here is that full method with everything highlighted so that you see it all in one place. Now there's another way we can decouple, and that's using MVP. And I'd like to talk to you about what MVP is. But first we need to introduce MVC again. This is a model that you may be very familiar with, but the tricky thing about MVC is that if you ask two people what it means, you probably get two different answers. And another problem is that it's unclear where to put your code. Does some of your code belong in the view? Does it belong in the controller? Does it belong in the model? And finally, it's difficult to test because all these three pieces are very closely tied together. So if you're doing any unit tests, you need to actually mock out all three at the same time. And then if your tests fail, you don't know which of the three components has actually failed. The view is the web browser and the widgets in the browser, and compared to unit tests, the browser is really slow. What you want is a test that runs in the JVM really fast. So this is a confusing model, and it's not clear how to implement it, and it really creates a lot of spaghetti. So we'd like to do something different, which is model view presenter. Here too, you can find out some variations But what we like to do is to put all the special application logic in the presenter. The presenter is where all the interesting things happen. We keep the view extremely simple. The only thing the view should do is deal with the DOM in the browser and deal with browser events. But it should be no business logic, no special things. The model is also very simple. In fact, the model is just the class we looked at in the very first slides, where we have some contact details, we put some properties in there, we have get and set methods, and that's it. There's no event handling, really simple. The presenter is a little bit special, and I said that's where all your logic goes. But one of the first things we do in the presenter is we define the view interface. Here it's called display. So we have this display interface. We'll talk about it a little bit more. But notice it has click handlers, get save button. Well, that display interface is actually implemented by the view, which is the widget. Now, this view is still slow. So what do we do about that? Well, because our view is really simple, and we like to make it fast, we can mock it out using something called GWT mock utilities. And here you see the desired scenario, where we don't use the real browser widget, but we use some fake widget, a mock. So here's that presenter in more detail. We have a display interface or a view interface. We have this has click handlers interface, has value. And what you see is that instead of having a button as the return type for get save button, we have this thing called has click handlers. Now, why do we do that? That's because has click handlers is much simpler than a button. The only thing that has click handlers has is you can execute a click method. A button is much more complicated. A button allows you to set text and maybe do fancy things with a style. But a has click handler, it just can accept clicks. So it's much easier to mock out. And it forces us to have the presenter only access that functionality that is needed there. So now if we want to bind to the display, that is, in the presenter, we want to capture, hook ourselves and wire ourselves into the display. When we want to do this, we call the bind display method. And it's very simple. We do two things, or three things. We first save a copy of the display, so we have a reference to it. And then we call get save button, which is a click handler, and we say add click handler to it. And then we implement an on-click method. We simply call do save. And we do the same thing for do cancel. So now when we want to start editing a phone, we call this edit phone method. And we do one thing first, which is make a defensive copy. That means make a copy to make updates safe. We say this phone is phone.from, and that's a static method which makes a copy. And we do this so that our local phone widget, we can make updates. We can update the phone number, we can mess with it. And if the user decides that those updates are not good and they hit cancel, we can just throw the model object away. We haven't changed some special original copy. This is where you see that there's a benefit to not having just one copy of everything. Now, if we want to, if we're done editing the phone number and the user clicks the save button, we call phone.setNumber. We copy the number from the display. Then we call the service execute method, and it's simply, when there's success, it does a teardown, which means to remove the display or remove the save and cancel button. If there's any errors, we can show them to the user. So another way to decouple is through dependency injection. Now, dependency injection is something you may have heard about and you're hesitant to implement because it seems complicated or a lot of work. But it's really just a pattern, which means you can do it. It means no globals. So you have no global variables that have some magic classes that everyone needs to access. You have no service locator. So there's no special class that you go to and say, give me the RPC service. That's away a global. Dependencies are pushed in, but preferably via the constructor. So whereas you may be used to passing in dependencies from one level to the next. So class A instantiates class B, which instantiates class C. If you need something in class C, you have to pass it in all the way from A so that it can pass through B to C. With dependency injection, you don't have that chain. Instead, the dependencies are injected in each constructor directly. And I have an example of that later. Dependency injection is not hard to do manually. In fact, in AdWords, I believe it's currently done manually, and that's because these two projects, Gin and Juice, Gin was not available at the time. Gin does client-side dependency injection, and Juice does server-side dependency injection. And I have a code sample that shows you the benefits there in a minute. Now this slide, I'm going to bring up some code, and I'd like you to read it from the bottom to the top, because that's kind of how the class was written. So first look at the very last line on this slide, where it says contact viewer.go rootpanel.get. That's the desired call that we'd like to make. And in order to make that call, we have to construct a contact viewer. So the line immediately above that, you see that we construct the contact viewer. But the constructor there has 4 parameters: contact widget, phone editor, RPC service, and event bus. So those are dependencies. So what do? We simply construct those. So if you read above that, you see those dependencies. Now in some cases, for example, the phone editor, roughly in the middle, you see that it needs a phone edit widget and an RPC service. So those are 2 dependencies. And we just keep creating dependencies manually, because we're not using dependency injection frameworks, until we get to the top and we've satisfied all the dependencies. So this may look like a lot of code, but it's really straightforward. You just construct everything you need and you pass in the stuff, and anything you don't have, you construct. Now, we have the same code, but let's say now we want to introduce Google Voice Service, and we want to add another dependency. We only make 2 changes. 1, we have to construct that new object, and 2, we pass an additional dependency into the constructor of the phone editor. And you see that we didn't have this chain where we had to make changes in multiple places. We just have one place right here in our onModuleLoad method where we make these changes. Now, I'd also like to show you what the exact same class looks like, but with a dependency injection framework. See the bottom line? It's the same contactviewer.go method that we want to create. But the thing that Gin does for us is that it does all the hard work of creating all the dependencies and injecting the appropriate dependencies where they're missing. So this is the benefit of something like Gin or Juice. Now, when you do decoupling, you get some payoffs. And the big payoff is that your tests run fast. You're mocking out the browser, so things can go really fast. I have a few slides here where we build a number of mocks. It's not too important that you look at these in details, but I point out a few things. So here we're creating a mock service or a fake service. And we're going to implement this contact service async. That was the RPC that we defined at the very beginning of this talk. And what this class does is when I call the execute method on this fake service, and I pass in an action and a callback, the only thing I do is I store the action and callback into local fields. Now notice those fields are package protected, and that's important as we later do the tests. This is something very simple to write, but what I'm trying to do is after the execute method is called, I can, in my unit test, verify which action and which callback were passed in. Now we're going to define a mock click event. This is a fake click event. It extends the click event interface, and then a mock click handlers, or has click handlers. It implements the add click handler interface. And here we do something very similar, which is we simply store the last handler that was passed in to us. At the bottom, you see an event, or a method called fire event, and it does nothing. That's because we don't need that for our tests. Now, we have another mock to create, which is mock has values. And we do something, it's very similar. We save the last value. And this is all code that a framework might be able to write for us, but we can also write ourselves. It is, again, something that looks like a lot of work, but these are tremendously reusable. Every time we create a unit test, and we should be creating hundreds of unit tests to cover our complex application, or maybe thousands over a very complex application, we can reuse these mock classes. And because they're very simple, they're very reliable. They work the way we want. We only have to create them once. Now, I think we have one more mock to create before we get our payoff. This is mocking the phone editor display. This is the thing that simulates the widget. Notice that it has no real widget functionality. It doesn't implement the button interface or use it. It uses that has click handlers interface. And so the save button there is represented by a has click handlers. So now we finally get to do our test. We've created our mocks, we can reuse them. First, we're going to instantiate a service. So we have a mock contact service. We just create a new one of those. We need a mock display, which is the view. We're going to create a new contact detail ID. That's just a value that we need. Then we're going to put together our before and after values for our tests. We create a before value, and we set a label home with a home phone number. Then we make a copy of that before value and create an after value. But we set it to a work with a different phone number. Okay, that's our setup. So let's run through it. We have a new phone editor. We pass in the mock display and the mock service. So those are fast classes that we can use to test with. And we call editor.editPhone, and we pass in the before object. So that means that the editor or the presenter is now getting ready to edit this phone entry. We, in the mock display, we update the label, which was home, to be work. We update the number field from the old number to the new one. And then we get the save button and the last click handler that was passed in, and we call onClick with a mock click event. So now, hopefully, our new phone number is saved. So we should verify that. So this is the rest of our unit test. We create we look up the last action, and we create a new action and compare the two to make sure things are as we expected. We get the actual phone number, and we make sure it's equal to the expected phone number. And we get the last label and phone number. And if either of these things are not true, then our unit test will fail and show us that we've created an error. So this is kind of the payoff. And this will run very quickly because these mocks are very small Java objects that will run very quickly. Now the third theme for today, which is to strive to achieve statelessness. First, I want to talk about disposable servers, meaning that it's okay if a server goes down, my user can connect to a different server. My user is not tied to that same server. It's very flexible to move on to another server. If I need to roll out a new version of the software, I can just reboot a server and users will go to a new one. It's important that we let the browser have the session and the state. So the browser knows where the user is, knows that the user's in step 2 of step 5 in a wizard. The server doesn't need to know about this. The server is effectively stateless, except for caching, which helps with benefits. But caching is only a nice to have, it's not a requirement. And I mentioned before, the user should not notice when the server is restarted. A good example of this is App Engine Memcache. And there we say values can expire at Memcache at any time. That means you can put values into memcache and you can get them out opportunistically, but they may not be there, so don't rely on it. The second type of disposable unit I want to talk about is disposable clients. Now, when a user presses the refresh button in the browser, or maybe their browser crashes and they start back again, that should be okay. When they hit refresh, your app shouldn't go away. You should just stay on the same state. So here you want to get GWT history right, and get it right early. By early, I mean early in the development life cycle of your application. Allow the back button to just work, allow refresh to just work. And be able to bookmark application state. As a developer, decide which points in the application make sense to be bookmarkable. If you have an enterprise application where someone can drill down into customer information, maybe that's a great place to create a bookmark so that someone can email the URL to another user in the organization, and when they pull it up, they go to the same screen at the same spot with the same information. There's a recommendation to use a place abstraction. This is something that I suggest you do above the history abstraction. So Google Web Toolkit provides you history support, and it's a bit too low level. So I would create a place abstraction, like a place in your application above that. And then you can take place changes, like when someone navigates from one part of the application to another, and announce those via the event bus, so that anyone in the application can find out about it. The third type of disposable object are the model objects. Remember in the very beginning with our spaghetti diagram that our model objects were in the middle, and they fired event change properties to everyone, and that there was only one canonical copy of every model object. If you instead make them disposable and have multiple copies, it can be much easier. And it can be easier because you can throw away those copies when you don't need them. You can allow multiple instances, and you can expect multiple instances. So know that when you make a change to a model object, you're not changing the only copy. You're just changing your copy. And so you need to propagate those changes through the event bus to someone else. So you recall this diagram that we created. If we want to add the place abstraction, we can just do that. So let's revisit what we talked about today. If you had remembered nothing else, I wanted to remind you to get browser history right and do it early. Use an event bus to fight spaghetti. It can really help rejigger your application, be more flexible, and hopefully make it less complicated work to do development. Dependency injection pattern plus model view presenter pattern for the win. These two things can really make you successful. There were three major themes that we covered today, which were to embrace asynchrony. So realize that the browser is an asynchronous environment. You can't block the UI thread and prevent the user interface from updating. You can't wait for the server response before changing the UI because it will be too slow. So because some things are asynchronous, why not just have everything be asynchronous? Now, one thing I didn't mention is when we created the asynchronous callback, we had an on success and on failure method. And you might say, well, I don't want to incur the penalty for this asynchronous behavior. Well, if you set things up correctly, you don't have to do that. When you call the on success method, or when your data is already there and you call the fake RPC service to request contact information, if it's in the cache, you can have your application return and call the on success method immediately, not asynchronously. The second theme was always be decoupling. Make sure the right side of your application doesn't know about the left side of your application. So this means that you don't have links over from one part of the diagram to the other. Everything kind of wires into the event bus, and the event bus wires into the RPC service. Finally, strive to achieve statelessness. Allow disposable servers, disposable clients. Allow servers to be restarted, allow the browser to be refreshed, allow your model objects to be thrown away or recycled. I want to leave you with a link to find out more about Google Web Toolkit, links to documentation and articles. There's also a large number of sessions that were given at Google I/O. You can watch these sessions and retrieve the slides. And want to thank you very much for coming today. Appreciate it. We have just a few minutes left for some questions. If anyone would like to ask questions about the presentation today, please raise your hand if you have a question. Question over here.
To run more the realistic example, can you tell us some the example service of Google which built on the this Web Toolkit?
Google Wave is built with Google Web Toolkit. That's probably the most exciting service in my mind. That's built with Google Web Toolkit. AdWords user interface, the new user interface is built with Google Web Toolkit. And so that's a very important application to us as well. Any other questions? If you do have questions that come up later, feel free to find me in the halls or maybe at the App Engine office hours where I'll be. Thank you for coming today.